let's look at lesson 8. Again, we're talking this week about animated sprites. And we're using that, again, Andy Harris's book as the primary, but there's other books out there, again, that you can look at online, as included in the syllabus, where you can get more information about Pygame and Python. I encourage you to read as much as you can, as well as the documentation that exists online on the pygame.org website. Okay, so we're going to talk about different kinds of boundary checking. We already saw one type of boundary checking, right? We look at the bounds when a sprite gets to a certain part of the screen, and then we want to do things like do a wrap. So the sprite keeps going and it appears on the other side of the screen again. We're going to use sprites with multiple images, right? We're going to think about delays in animation, because sometimes you need to put delays in place for the animation to work properly with sound, as an example. Different states for the sprite itself. For example, if you move up with a particular sprite, an avatar sprite, as an example, and then you go move down, you're going to have different states, different graphics that will take place for the different directions that you're moving your avatar, right? I mean, it makes sense. You want your sprite to move in the direction that you're, or change direction and change the angle as it walks along or moves along. We're also going to, and this is over the next, again, this class and next class, in terms of how we rotate and resize an image. We can do that within Pygame itself as opposed to doing it in a graphics program. Again, there's advantages and disadvantages to both approaches. The calculating motion vectors, again, we're going to use a simple formula for doing that. And again, we're going to do it in radians as opposed to just angles. We need to do that when we're working with computer programs in general. It doesn't matter whether you're working in Python or C++, Objective-C, whatever, what have you. It's usually in radians that we calculate our angles. Okay. So let's talk about boundary reactions a little bit. So there's a few different kinds of wraps and scrolls and so on that we can do. So again, one of them is the scroll, right? So when you get to the boundary, it scrolls, right? When your sprite moves to the boundary, it wraps. In other words, it comes in one side of the screen and then wraps back to the other side. What does that mean? So let's look at that. And I'm going to be using Fireworks for some of these examples, only because I like Fireworks. And the sad thing about it is, and I know I'm recording myself here on, it's going to be on YouTube, but Fireworks is not being continued for Creative Cloud because Adobe has a different direction that they're going to be going with. So you've got Dreamweaver and Creative Cloud for the new stuff, and I know I'm probably going to be dating myself in these videos, but that's what it is. And you're going to have Photoshop, Illustrator, that whole part of the suite. But Fireworks, which is kind of in between it all, right? You've got a little bit of, vector graphic capability in Fireworks. You get a little bit of Photoshop kind of image editing, and you get a little bit of, image optimization for the web and so on. There's not really a product out there that does kind of the same things in one as Fireworks right now. It kind of, hits a small niche, of people that need to use it. So, and I use it again for different graphics and so on. So let's take a look at that. So I'm going to pull up my my plane GIF here. Here's my plane again, and I'm going to create my canvas. I'm just going to create a new document here, and I'm going to do a 640 by 480. So here's my my canvas itself, and I'm going to grab my plane, my nifty little plane, so we can kind of describe the different kinds of scrolling. So again. So let's say I have my plane, it's moving from the bottom of my screen, so my plane is moving, this is my sprite. And as I move to the top of the screen, it wraps. Well, a wrap, what it means is, as I leave the screen, it comes right back down here on the bottom of my screen. It kind of reappears and wraps down, almost like the world is, and I'll let my my Fireworks spin. It kind of comes back onto the screen. So it keeps wrapping off the screen and back on the screen. And it keeps on doing that over and over again. Whether it's on this this boundary, or if it comes from the left and goes to the right and then comes back onto the left again, as an example. That's more of your wrap. So it comes off the screen. So here's my image off the screen, and then it comes back on the screen over here. I don't know what happened to my plane. So that's really what a wrap is. Okay. So then we have a bounce, right? Well, that's pretty self-explanatory, right? So, you know, you have my plane. Now, a plane might not be the right thing to bounce with, but imagine if I went to the boundary and I went boop, and I bounced off again, right? It wouldn't allow me to leave the boundary of my canvas, right? So that's another kind of boundary collision type, if you will, right? And then the next one is a stop. So that's more common. So let's say, for example, instead of it being a bounce or a wrap, I don't want to let my plane go further than my screen. I want to stop it left or right or top or bottom because it doesn't make sense that my avatar is going to leave, you know, the control of the player kind of thing, right? So it's kind of a stop. That's another kind of boundary. The other one is a hide. That's a different one where you can kind of hide your, you know, your avatar. So it kind of, when it gets to the boundary, it kind of, you know, peeks outside the boundary and it's gone. You can't see it anymore and it comes back, right? Kind of a different kind of technique. But these are all kinds of boundary checking that you're going to be doing with your code, right? You're going to be looking at it and you're going to say, where's my avatar? Where's my sprite? What is it doing, as an example? And then how do I want to respond to it as it moves in and out of the screen or towards the boundaries? Okay. So let's talk about wrap.py. This is our first one. And we're going to create this reusable sprite idea that we're going to use. The ball is what we're going to use, right? And it's going to draw a path in the screen as it travels, right? So it's going to draw behind itself. As it goes, it's going to draw a path to see how the ball is moving. All right, so we're going to look at wrap.py, and that's under your archive, code archive under lesson 8. Okay, so here's way down here. As you see, there's all kinds of images here. Here's wrap.py. All right, and let's see what it does. Let's just run it to see what this program does. One day it'll start. And there you go. So as it goes, if you notice, you've got a ball moving in a diagonal direction, right, as an example. And as it moves towards the bottom right, it wraps. And it's going to keep wrapping forever. Right? And if you notice, it's going to be slightly different. As it moves, it's going to create a pattern on the screen. Right? As it moves off the screen, it continues to wrap in a different location depending on where it wraps the screen. Now, this is a neat effect because if you notice on the screen itself, right, when it moves over here or here, right, it wraps down here, right? Moves over here, it's going to wrap over here. And why does it do that, right? Well, because of the algorithm, obviously. Let's take a look at that piece of code. Yeah, it could be, yeah. Screensaver, they've done things like that for screensavers before. Okay, so again, you have your import statements. So going back to your, in the idea framework, I for initialize, import initialize. So there's your import. You're going to initialize. Now we're going to create this ball sprite. And again, going over sprites and classes. I'm going to continue to review with you so until you get sick of it. Right, but basically the way it works is this. You've got your sprite, your ball, which is a subclass of the sprite class, superclass, right? You've got your constructor, and in your constructor itself, you're actually listening for two different arguments. Screen, which is the top level window, and background, which is the surface, you know, of the window on that's one level up from the background window itself. Okay, so those two things. You're creating two fields or class variables, if you will. Screen, which is equal to the screen that you're getting in from your constructor, right? And background, which you're getting from the argument background, right? So both those variables are getting their values, if you will, or they're actually getting their reference to the top level window and the background surface. Okay? And then you're creating an image. In this particular case, it's the image of the ball, a surface image, which is 30 by 30 pixels. Okay, so that's what you're defining the surface, a new surface, for the ball itself. This is defining the size of your sprite. You're filling it, in this particular case, the surface of the sprite itself with a white background, right? 255, 255, 255 is all colors turned up, and that's your white background. And then what you're going to be doing is drawing a circle, right? And you're using the image surface as the place where you're going to draw the circle, right? And the circle is going to be blue, right? Because RGB, here it is. And the circle diameter is going to be 15, right? So 15 by 15 is going to be how, it's actually an ellipse is what you're drawing, right? And that's the position, really. The position is of the circle itself is 15. So it's drawing a blue circle in the middle of your white square. That's the surface. And that's why we're seeing that surface object. It looks like a circle, right? We're also going to define a rectangle, and we're using the getRect method, just from like last time, for this sprite, which we're creating the boundary terminology for the actual sprite surface itself, right? So remember, the way we're getting top, bottom, left, and right, and center, all those kinds of labels for your sprite is this getRect method. If you don't use this getRect method, you'll never have a top, bottom, left, and right. You need to use it. And then, of course, we're saying, well, once we've inherited this this method, right, as an example, it also comes with some other features, these properties. For example, a center property, we're defining of where the actual sprite is going to appear on the screen. It's going to appear at 320 by 240. So that's where it's going to start off, in the middle of the screen. Okay? Then we're defining a delta x and delta y of 5, which is the number of pixels that we're going to be using for us when we do our update. So it's going to actually move to the right and down 5 pixels every frame. That's what it's doing. Okay? Here in the update, where we actually change the sprite center itself, we're saying, I'm assigning my old center. I'm creating a temporary variable called old center, and I'm saying old center is equal to the actual current center of my sprite. And then what I'm doing is I'm changing the center x and center y with the delta x and delta y values that I've assigned, right? And then what I'm going to do is I'm going to say, well, draw a line between my old center, right, which is right here, and my new center, which is the next. When I've incremented my, I've added the delta y and delta x numbers to the position of my original sprite, I'm actually moving it down, and I'm actually drawing a line, from the old center, which I've taken, whatever that was. In the beginning, the old center would be 320 by 240 in this particular example, right? And then the first frame, it's going to go to 325 and 245, right? And that's going to be the new center. So it's going to draw a 5-pixel line, very, very small line, between the old center and the new center. So that's where the line that follows comes from. If you notice, there's a line trailing after the circle, and it comes from this particular piece of code right here. Then we're going to call checkbounds. Every update, every frame, we're going to check to see if we've gone outside the boundary. Okay? And then our checkbounds function is actually right here, and we're doing a wrap. Right? So we're saying this. Here's all of our if statements. So for those of you who can look at conditional statements and understand what this is doing, it says if the center x is greater than the screen width, which means as my sprite approaches the right side of the screen, I'm just going to go back here. So let's say, for example, once I go here and as I go, my center x, the center of my sprite, which is where my mouse is right now, my mouse pointer. Once it approaches the center of the screen, that's what it's saying, right? So this is where my mouse is at the center of the screen in this particular example. It says, well, then my center x is equal to 0. So actually wrap it. So it basically says from here, move it back over here, right? That's the first thing it does. But simultaneously, it also says, if my center x is less than 0, right? So if I'm actually outside of the screen itself, right? Then what I want to do is I want to move it to the right, to the other side, right, where my center x is actually equal to the screen width. So example would be, I'm just going to shift back here. If I move over here, it's going to shoot me over here, right? So it's going to wrap me depending on which direction I'm going in. So it kind of handles both sides, right? Now the y values, right? So if my center y is greater than this, which I'm going to call the height, right? Then what I want to do is I want to assign it to 0, the top of my screen. So let's look at that. So that means if I go to the bottom, that's the height of my screen, because remember 0, 0, and this is a good example here. And in Fireworks, if you notice over here, right, as I move my mouse pointer to the left part of the screen, the top of my rulers here are showing me the coordinates, right? So here's 0, 0, and this is exactly what it's like when you're, kind of defining your sprite. 0, 0 is the top left corner of my screen. And by the way, in Fireworks, you can pull it down to make it wherever you want. I can center it so it's like top left corner of my screen. Here it is. Or I can move it somewhere else if I wanted to create a new 0, 0. But as an example, as it approaches the bottom of my screen, which is the height of my screen, then I'm telling it to wrap this way, right? At the same time, if it goes diagonal, right, so I'm going to go in a diagonal motion, right, and I'm saying, well, it's here, right? Well, it's going to wrap it over here. That's why it wraps it that way, and then it's going to keep moving it this way. That's why it creates that pattern, right? Because what I'm actually doing is saying this. If my x direction, right, this is why it's creating that weird pattern. So here's my my object. I'm moving in a diagonal direction. So let's take a look here, guys. So I'm moving it here like this, down, 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 down. And as I reach this part of the screen, right, it wraps first over here, right, and then keeps going down this way. And that's why you see that weird wrapping pattern. Then it comes over here to the bottom, then goes to the top over here, and then starts from here down this way. And that's why you see that weird wrapping motion, right? So you have to understand the algorithm for what causes the way our avatar wraps on the screen itself. Because you'd expect, theoretically, right, again, that if I'm coming this way, that I would wrap up here, which is not the case, right? If I come here, right, how do I calculate it coming back up here? You can't, right? I mean, you could, but there's a more challenging piece of code that you'd have to write to do this, and for it to keep going along this axis, if you will, right, in this particular angle over and over again, right? It's easier for you to do this, right, as it comes down here, right? You wrap it on this side first, right, and then keep going this way, and that's what the actual code does. All right, so let's go back. Oops. That'll be okay. So that's your boundary checking right here, and it does both sides. It does if it's one side of the screen or the other side of the screen. It kind of creates all the code you need here for all the wrap boundary checking. Okay. The rest is really defining the size of your screen, creating your caption for the screen itself. I'm creating my background as the surface of the size of my top level window, right? I'm filling it with a white color. So the screen itself and my sprite, in this particular case, have the same color, and that's why you don't see a square moving along the screen, because otherwise you'd see this big square with a circle inside kind of chugging along, right? I'm actually blitting the background to 0, 0 on my screen itself, because I say screen blit. So display on my screen the background at position 0, 0. I can position the background in any place I want, right? In this particular case, I'm just saying in the top left corner of my screen is where I want to put my background image. The ball that I'm creating is actually, I'm defining it as a ball sprite, which I've created the class, and I'm passing in there. This is why I passed in the top level window and my background surface. I passed that into my class in order for me to reference where the ball sprite's going to appear for my game. And then I'm creating an all sprites group where I'm actually including just the ball sprite, because it's a good practice or best practice to create an all sprites group that includes a compressed amount of sprites, so more than one sprite that would be updated at the same time. In this particular case, we're only updating one sprite because there is only one ball sprite. But we don't have to do that. We can have many ball sprites, which we'll do in a second. And I'll show you how that works. So keep going. Again, this is our main game loop, and I'm reviewing all this stuff over and over again to help you guys. I'm going to say it over and over so that whether you review the video or you're in class, it kind of clicks at some point. You need to have a game loop in order for your game to continue. I'm creating my frames per second, my clock tick. I'm setting my frames to 30 frames per second. Right? I'm checking for all events with this pygame event get method. I'm saying, hey, I'm listening for everything. Okay? And then I'm only checking for the pygame.quit event, which is actually the X at the top corner of your top level window, right? And if it's true, if you press the X, then we stop the game. That's what this does. Otherwise, I use my all sprites group to clear the screen and the background, update the sprite, call the update method for my ball sprite and all sprites that are in this group, and then draw them back onto the screen itself. So I update basically the positioning of the sprites and redraw everything, just redraw the screen, and then I use my double buffering so that way there's less jitter. So really that's the code itself in a nutshell. That's what does everything. So now that I've defined the code for you, this is your challenge, right? Tell me, if you could think about, if I wanted to have a second ball sprite, right, and I didn't want them to overlap, right, I'm going to have to pass something else into the constructor. What would I pass? Anybody? Right? So I have a constructor right now that takes a screen. So that's my top level window and my background. Okay. I also have my delta x and delta y, and I also have my my center, right? So my center starts off as a tuple of 320 by 240. But if I wanted to have multiple ball sprites with customized center, what would I have to pass into the constructor? Anybody? Wow, we got a sleepy room this morning. The center. We'd have to pass in a center variable, right? So if I did that, let's modify our class for this example. So here's I'm modifying the class. I'm adding a center variable, right? So I'm actually listening now for an additional variable when I create my ball sprite, right? And I'm going to say this. I'm going to say, well, center or self.center is equal to center. That's the first thing I want to do. So I say, whatever I pass into this argument, I'm passing into the class. I'm taking it and creating a class variable, and I'm passing in that information. I'm referencing that information into my class variable. And I'm hoping that this center sprite, the center information, is going to be a tuple, because that's what I want, right? It has to be a tuple. All right, so that's the first thing. And then I'm going to say this, just to be clear. Self.center, right, is equal to 320 by 240, right? Because I want to have kind of my my initial center. If I do that here, whatever you put in here is going to be overwritten, so that's not cool, right? So I probably want to do it, instead of here, I probably want to do it up here. So I want to kind of have a default 320 by 240 tuple. So if you don't put the center in, if you put center as 0, or don't put it as center, then I'm going to assign 320 by 240 into my, as my center, as my default. Okay? So this way, I don't have to actually put this in at all. I can actually remove this this line altogether, right? What I want to actually put is here, self.center, right, is where I want to put it in, right? So that's the first thing. So I've made a change to my class. So now I can define different balls on my screen. They're all going to be blue so far, right? But they could be a different position at different places. Okay, right now. That's the first thing. When I create my ball sprite now, I've got to add in a tuple, right? And I can put in 325. Here's my tuple, 325 by 350 as my tuple for my ball. And when I run this, just like this, one ball sprite, if I've done everything correctly and I run the code, right, it'll position in a different place. So here's where my ball sprite started, right? Let's look at that again. So now let's change that. Instead of 325, let's make this 125, right? So now I'm changing the position of my ball sprite somewhere else on the screen, right? If it works, there it is, 125, right? So now that I've been able to do that with my ball sprites, because I've added in this additional argument here, where I'm passing in a tuple, right, to change the center of my ball, right? I've added in that capability. I've changed I've customized my ball class now even further to create an ability for me to add in the center of my, of where my center of the ball is going to start, center of my sprite. And if you notice, again, I assign a default value of 320 by 240 if it's not used right, right? If I leave it blank. That's the first thing I've done. Okay, so now if I want to assign multiple balls, right, so there's ball number 1, let's say, right? And I also want to put ball number 2. So let's just copy this whole line. I want to have 3 balls moving all at the same time. This is our first part, right? So ball number 2. And this time I want it to be, I'll put this one at 320 by 240, just for this illustration. I don't have to. Right? And this one I'll leave at 125 by 350. just to make it different. And I want to, of course, add them into my class, into my group here, my Sprite group, ball 1 and ball 2. Give some separation in the code here a little bit for you so you can see that, ball 1 and ball 2. And now when I run the program, I have 2 balls, right? Because I've got ball number 1 and ball number 2. And now they're moving simultaneously down the screen. And they've got the same properties because they're using the, I know you're laughing, Haley. I got 2 balls, right? I got, on the screen, right? That's very good, very good. See, at least some of you aren't sleeping. Not all of you are sleeping on the class, right? But if you notice, there's 2 objects, there's 2 sprites, 2 ball sprites that are moving down the screen. And they're moving and they're wrapping at different positioning because they're starting at a different place. Okay, let's do 3, just to make it more interesting. And we'll actually add an additional argument here to make it even more interesting than that. Okay, so here's ball 3, right? And this time we're going to position it at 50 and 50, right? Here's 50 and 50, and we'll add ball 3 into our Sprite group here, right? And we will run this. So I've got 3 balls now, right? So again, if you notice, there's 3 different objects moving in the same direction. Okay, they're all moving in the same direction, and they're wrapping according to which part of the screen they appear. Okay? Like meteorites falling in the sky, right? But this isn't really that interesting with these different objects. What if I want to add in something else? So here, let me go change my class again. So I've got my center, but now maybe what I want is I want to change my dx and dy values and have them something that's customizable as well. So I add in my dx and dy value up here, right? So now I do the same thing here. I say, well, guess what? My self.dx is equal to dx, right? And my self dy is equal to dy. That's the first thing I want to do. So I've kind of created all the constructs for my variables are right here at the top. And I also want to assign a default value to these just in case you don't put dx and dy values, right? So here we go. I'm adding in dx and dy. So I can take these ones out now. I don't need them anymore, right? Because my dx and dy values are going to be assigned as I go. And now when I come back to my sprites, my lovely sprites down here, I'll leave these as 5 and 5. That's my dx and dy value. But here in my dx and dy values, I'm going to actually put a -5 and -5 for this ball, right? And for the third trick, right, my dx and dy values, I'll put a 1 and a 10, right? So more of a steep kind of, traversal, right? So let's take a look at how that works. So I've got different values in here, and now I've got different balls going all over the place, right? They're all crossing over and doing, they're having different patterns, right? How did I do it? Again, all I'm doing is I'm modifying my class, right? That's what I'm doing, to give it additional customization. I'm adding different variables inside my constructor because the constructor of the class is where I'm actually defining my object, right? So my object, in this particular case, ball 1, ball 2, ball 3. Let's take a look at that. Here's ball 1, ball 2, ball 3. These are my 3 objects I'm instantiating. And I've got the ball class, but I've added in, again, a tuple for my starting, my x position, and my dx and dy values. Now, if I took this out, as an example, because I've added in default values, and I run this again, right? So I don't add anything. It still works because I've added in my default x and y and center x values. And that's why it's important to kind of have some kind of defaults if you're going to have overloaded constructor equivalent what I'm doing here. I'm kind of creating an overloaded constructor. I'm saying, depending on which values I add in, now they have to be added in the same order, right? As an example, but it creates an opportunity for me to whether I want to add in an x and y value and dx and dy change in values or not. So this is kind of a fixed approach, right? But if I really want it more interesting, even one more step, we'll take this step here. I want to import random here, right? And now I'm going to kind of create a random value. So what I want actually for one of my balls, sprites, so I've got kind of like, here's my default. This is a default sprite. This one is kind of a negative sprite that's going in a negative direction, right? But now I want to kind of have a sprite that kind of goes in, it starts in a random location, right? So I'm going to put in random.randint, right? And then I want to say, well, I want to start off with 0, and I want it to, I believe it's screen width. Screen, oops, dot, what was the actual command? I think it's get, screen dot get, I think it's width, x, and then comma, so that's the first thing. So 0 and screen dot get width, that's the first one. And then the next one, I'm going to start off, right, with making sure this is all correct. Randint. I'm probably not going to have enough things here. 1, 2, 3, 4. Same thing goes here. Randint. Dot randint. And then I want to say 0 to screen dot get height. If I'm not wrong, right? So that's the first thing. So kind of a random location on the screen. The ball is going to start off. If I've done everything correctly, I shouldn't have an error. Right? So that's the first thing. So it's going to start at different positions all the time. Let's try that again. Right? There it is again. So 3 different. And I also want to change the randint values here. Now this is going to be a long line, so I could theoretically continue the line, a new line, but let's just do it here. So I'll say random dot, I'm just going to go off the screen here, randint, and I'm going to go 0 or 1, sorry, to let's say maybe 10, sorry, to negative 10. And this one will be the same thing, random.randint, I'm going to go off the screen here, 10 to negative 10, or maybe negative 10 to 10. That's probably what I should probably do, just because it gives me the right ratio. Also give me an error, because I got to start off left to right, right? And if that's true, then I should have a sprite that goes in a weird direction, right? It should go, whoo, different places, right? Oh. So now I've got sprites going all over the place, and it's gonna go in a random direction all the time. So it'll be a random location and a random direction. So here, let's try it again. There it is. Another angle, right? It's going to look a little differently. To really illustrate this, instead of using all these 3 different ones, I'm just going to include only one of them. So I'm going to comment out ball 1 and ball 2, only leave ball 3 in here, and just take out these ones, right? Okay, so here's ball 3. That's all that I'm updating now. So now I have a random sprite that starts off, if you notice, start off at that location in that direction, upward, right? Okay, and now if I launch my code again, just to illustrate this one, starts off in that direction, different place, right? Very flat, so obviously it's a 0. It's not going to produce any more lines here. Let's try it again. Third one, really slow, so not, but moving backwards, and a 0. And let's try another one. Really fast, moving to the right only, and another 0, which is interesting. Hopefully it won't be too many more zeros. There's another one, moving in a diagonal very quickly, right? So if you notice, the sprite, I've customized the ball sprite so I can make it move different directions at a random location. Okay, why did I bother doing all that with you? Because, theoretically, the ball sprite that we just created could be your enemy, right? You're making a random screen, and you want the sprite to appear in a specific direction or a specific place on the screen for this particular game screen, and you want it to go in a specific direction at a different speed. Here's an example of how I've done that.
Can you go back to the constructor?
Yeah. So let's take a look at fiddling with it.
Well, I have like power-ups for my game and stuff like that, and I realized I also have like these random objects that you can hit, and their properties are a lot of the same. I just need to basically change the image in the start and end screen.
Yeah.
So
So
I
there.
think I'd just do that in the constructor, save a lot.
I think that's the that's the right approach. Here's the constructor that I've used. So again, in my constructor, and we're going to break in 5 minutes, just to give you guys a chance to get away from my raspy voice. Is I've added in a center value, and I've defaulted the tuple that I'm going to use. So even if I don't add in my center and my dx and dy values, I've kind of created almost like some default values for those things. Right now, if I didn't do this, and if I left this out and this out and this out here and this out here, it would error out. If you're instantiating your object, right, and you don't have the arguments, they're not filled in, it's going to say, hey, you're trying to instantiate an object and traceback, I don't understand, you haven't given me enough information to create my object, right, because it's requiring those things. This is whatever's put in the constructor is required. Is there another way we could have done this without using the constructor? There is. I could have actually updated my self dx and dy values. As long as I've defined them here, I could change my dx and dy values inside the code itself after I've instantiated my object. How? Well, down here, where once I've defined an object like ball3, well, ball3 has a bunch of different properties now, right? So I go ball3 dot, and I look at all the different things I can do. I can actually access my dx and dy values right here. This is another way you can do it, right? You don't have to do it in the constructor, right? So if you want to avoid all this, all these lines of code here, right? You could, right? Now, I personally like it in the constructor because it actually defines my my sprite very, very clearly, right? But if you notice, like I said, because these are objects, they inherit all of the methods and properties, or fields, if you will, of both the default sprite class as well as my subclass, which is the ball sprite. Okay, so it inherits both of these things. Okay, so let me just deliver that and get that out of there. Okay, and let's put this back the way it was. So I'm going to go here and I'm just going to take out this, and I'm going to take out these comments here. So I'm going to put these balls back in play, right? Ball 1 and ball 2. Okay, and again, if you want to see how this works, multiple balls here juggling, you're going to see balls going in different directions, like I said, and I've done that by changing the constructor value in this particular case, in this particular example. So moving sprites, and I'm using the wrap boundary collision method for me to move the sprites off the screen and back on the screen, creating this weird pattern here. Right? But like the Guardian said in Star Trek, many journeys are possible with this kind of stuff, and it really depends on how you want to take it and where you want to go with it. Let's just change everything back to the way it was. So my next class, I can have fun with them too. I encourage you after the break to kind of play around with some of the stuff that we're doing here, right? Because what you want to do, and I could theoretically what I should have done is created another file, but I was a little lazy this time around, so I just put it back the way it was. That should be it. One ball, one sprite, no wrap. That's the original file. Okay, yeah, I could have done it a little differently there, but I decided to be a little lazy in this particular case. Okay, let's take 5 or 10. Go off and have your coffee and smoke and everything else, and we'll be back in